You guys play the minute we had currently.
No, not yet. No, I was video yesterday.
Change the life.
Let's see. So I still at the moment considering this switching over, getting out of Windows.
It's smart. It hurts for like 3 days, and it's over. You'll be better off forever. All right, go ahead and log into Bora. All in. Oh. I brought some chocolate because it would be a bit neat. Yeah, you'll want the chocolate. All right, you're making yourself a brand new bash script called buildproject.sh. And it should be pretty simple. I want it to automatically take one user argument, the name of a project, and then build out a directory structure under that. So when you run this script, it should make a project called whatever name you give it. See my example there. So build project.sha tumor transcriptome. So it made me a project called tumor transcriptome directory. In it is data, then data is raw and clean, and then it's also got scripts, output, and this empty readme. Write the script somewhere useful to you, and then add executable permissions. And then run this. So the GPT correct for this.
You're even reading too,
That's just an empty reading file.
so you don't have like these steps in.
No, I'm just gonna watch you running scripts.
Okay.
But just be clear, the script should make that. You know, you're ready. Yeah. So you're close, but you hard coded in the word. Script it should be, the user should provide the name. My example. No, so I'll just make that. Good one. Oh, it's a programs. Okay. There you go. Alright, I'm gonna call it here. This is not great. So check yourself. And let me walk through it as my. Yeah, I'm gonna go to programs. Just for it. Right. Nano build project sh. First thing is always thing, then bash or bash script, oops. Right. And then over. It needs to make some name that the user provides an argument. Data script. Okay, so we'll do this. Make directory. Do the P so we can create parent directories. The first argument is denoted how in script. $1. So I'll put that in the safety brackets. And I'll make output and scripts and data inside of data raw and clean. So far so good. And then I'm gonna touch $1 MD. Save that. So chmod plus x build project. Okay, so turn nice and green. Build project, some name. Got the README, I've got data raw, data clean, scripts, and output. All right. That's what I can. The curly braces, and we're gonna spend more time on this today, but remember they're like a safety thing. If I tried to do this $1 / output, it would look for a variable named 1 / output. So the curly braces say this is the variable name. And then anything extra is just like kind of appended to it. And so this gets expanded to $1, which is the user input, so whatever that first argument is, so that it gets to the script. And then you can read our / and the other stuff without thinking that's part of the variable. So the sloppy way of doing this would be make dir $1. Go into $1. Make directory data. Go into data. Make directory raw. Go back 1 the main. Make directory output scripts and touch. Then probably cd ... get out.
Why do you say $1 rate with like without
Because it's always $1 consistently will be the first argument to that script. Throughout the whole script, so it's suddenly reserved. So if you give an argument to a script, it just becomes the variable 1. And something that I see a lot, and I do this sometimes, but it's kind of nice, is I don't want to remember what $1 is throughout the whole script. And so right at the beginning, I'll set like a new variable, like project name equals $1. Then if I'm wanting to use that argument later on, I would refer to it like that. So it's just kind of like it makes it a nicer thing for me. When I'm debugging, I'm like, oh crap, what was $1? But if I see project name, I'm like, oh, I have that. Okay. So how'd it go? I'm happy, I'm less happy. Anyone very sad? If on a scale of 0 being I drop out of school forever, go work at Taco Bell, and 10 being like school, I'm gonna like take over the coding for Taco Bell. If you're below like a 4 or 5 right now, you gotta rethink your practice and study habits or how to learn this stuff. It's different from learning the bulk words in the biotext or whatever. This is a different kind of study, and it really is that muscle memory. You don't do this stuff over and over in your free time. It's not your free time. This is your mandatory practice time. Then this is gonna feel a lot harder than it should. Okay, so that was a bit mean of me. But I did bring a lot of chocolate because we got another pop quiz. You're not making a script this time, just a real straightforward for loop. Loops through the numbers 1 and 10 and then prints out for each one. The current value is colon space, whatever number it's currently iterating through. Hilarious if I have another pop quiz after this. Give it a little sleepy time. Okay. No sleep, okay, that's all right. Yes. Go to sleep in there. Excellent.
So you're having them sleep before it does that, go, it doesn't really.
Let it rest up before it has to work each time.
Can you expand and give it like the line by line in there?
You just hit enter after the 4, so line by line, and this isn't really recommended unless you're writing out a script. If you're just here at the prompt, one line is nice, but for I in on. Just hit enter there,
And then you start
and then you can say do echo whatever I.
and you don't recommend doing that? Or-
No, because if I hit the up key, it's gonna throw it all in one line for me. Anyway,
Mhm.
so that's how it's gonna show up in your history.
Yeah.
So I mean, you can do it that way, if you'd like to, but you'll never find it like that in your history.
And then, just like stylistic question, like, do you usually do spaces after the semicolons, like, to break it up, or do you just do it like right next to it? Or-
Obviously, like, look, I did
Yeah,
twice and didn't once,
so it doesn't affect.
it doesn't affect it,
Okay.
yeah. And that's because the semicolon really does mean end of
Yeah.
this command. Wait for next. It definitely, spaces do matter sometimes in Bash.
Mm.
So if I'm setting a variable, I can't do a space. That. So variable assignment can't have any spaces.
Mhm.
But I could easily make 2 variables on the same line just by using the semicolon. Oops. Okay, the next part. It was funny enough to do the 2 in a row. That's okay. Questions about what we did? Lingering, I'm not really sure why this worked. How do you put it on multiple lines? Yes,
Is it not when you put the sleep?
now the sleep is just gonna sleep right when it sees it, so since I put it. Before. Right here. Before it even prints the first echo, it's gonna sleep 1 second. I don't know if you can do a half second, or try it. Oh, yeah, I can. Neat. So if you needed it to sleep at a certain point, you can just put it in that order in your folder. The only time you would need it to sleep is if you're doing dial up with some remote connection. Give it a little break. A lot of websites, if you repeatedly query them over and over and over, they think you're a bot, and so they shut down your access. So web pages have this robots.txt file that gives you. Pretty much every website has this ways to get around that. One of the things is like sleep 3 seconds between each query. Dope. You all made it through lesson 4 on your own, so we're gonna scooch on over to lesson 5. We're all logged into Bora. In there, you can see this little path. So I've stuck some data files just in my own personal directory on HPC, but I made sure that you have read permissions, so you should be able to copy everything you find there. So go ahead and pull up lesson 5 and you can just copy paste that. Copy them into your biocomputing. You won't have to go in there, you can just copy them straight through that path. I list everything in there. Oops, wait. Okay. Those should be all the files that you're pulling in.
So you want us to put this into a directory in our biocomputing?
Somewhere, if you got like a folder for lesson 5 or something. In your biocomputing, you're gonna be working on.
That's this version.
Same.
Yeah, cannot stack.
You guys have read privileges. Anyone else? Isn't that same? Okay. Let me try this. Got write permission. Still no?
And we're just copying them.
You can't copy them?
Yeah, again, the CP, colon, you cannot stack your thing.
And then a permission there.
You have permission to that.
We're gonna put these that you can all access. But this would be way easy.
It might
Or some
be
other
that,
APCs.
maybe like, sometimes I
I'll
can
stick
like,
them in scratch space.
yeah,
Okay. So I'm gonna copy all that stuff into Scratch 10. Lowercase biocomputing. First, I need to make that directory. Here. Okay. Out there. Come on, 777. Everything. Okay. And that path I will change out here. Your home scratch pen biocomputing. Lowercase.
yeah. So it's a scratch on something like specific to you, like your user. I thought it was like organizing.
Oh, it is. Where can we put them?
I think we can access your scratch thing.
I think you should be able to. So. Let me copy this. The scratch spaces. The Wild West.
No.
Yeah.
Seriously? No, they were.
It's not much.
Yeah.
Okay.
All right,
Maybe it's in there, scratch. Wait, is scratch done? Did they send an email saying there's like?
It's fixed.
Probably grab it.
okay, I can't make anything here. Bullshit. Are supposed to share files with each other. I will talk to admin, see if we can fix this later, but we need to find a spot where we can all share stuff. Can you?
Let's see.
I don't think you can. And that was the problem. Oh, yeah, make biocomputing there. Um. Okay, fine. I'm gonna stick them on GitHub. Yes. Um. All right. They are right here. There. All right, this is a pop quiz for me. I'm super failing. All right, I'll stick them in my biocomputing repository. They're all pretty small files. There they all are. Um,
Yours is
I'll copy that.
where's it?
Yeah,
You try making the directory like cd cyclone slash crash 10 slash Gzon, that directory, rewrite exactly. And there's like two versions of it. It's like you have
what
like
was
a
it called?
cyclone, scratch 10, and then your username instead of home before that. The cyclone, yes, and then and then make that
Make that directory.
yeah, or yeah. Or no, that's
Oh,
already a
it
directory.
exists.
Make it like so we can read and write that.
Okay.
You want us to do it like this way?
Yeah, let's try this first. We are up on GitHub also.
Right, it's in the bottom, over in your.
Root, cyclone, Skirtan, Gizon, Biocomputing. Yeah. Okay. GitHub it is. So there's the URL.
And then should we just like getting something that just is like lesson?
It'll take you to this. You go to that URL.
Yeah.
There's all the files. How can we get them all? wget, but you're gonna have to type in each one of those files. That super sucks. So here's what I'm gonna do. I'm gonna ls1 here. Okay. And I'm gonna send that to a new file called 2. And I'm gonna nano. Make a little script to download all these. Homes. The home key.
So.
Home. You don't have a home? Ooh. Sorry. Yeah, Windows has a home.
Oh, yes.
Command left arrow. Okay.
Okay, cool.
So now you get to watch me like flailing around. I'm gonna make shebang, bin, bash, and then wget. Oh damn it! I don't want to type that all these times. Okay. Get rid of that. So I'll do a while read loop. I haven't taught you yet. While read line. Do wget line done, and I'll send in this file too. Or I'll just echo. There. So it printed it for me. Bang and bash. So I'm making myself a script. Gonna get all those files. I shouldn't have put a space there though, should I? Because then putting slashes the whole time. Ah. Okay, download data.sh. I'm gonna copy this whole script. Since you can't even access it apparently, no matter what. And I'm gonna stick it here in lesson 5. You can copy and paste it. You can see that I can make it a little prettier.
So we should make our own script that's,
Yeah, and they'll just have these contents.
yeah.
You go to your like lesson 5 notes directory or whatever, wherever you do stuff in class. This. Make yourself a script, those lines, run it. Work. That was annoying. That's totally new to me. Normally, like,
Yeah, that's, I felt like I could see
permissions,
into the.
yeah, you can like see in. So that's just the admins locking us out, but I'll ask them about making sure that you can all get access to my directory, making sure,
I can scratch that, I can see into other people, so
but not mine.
that is. But yours is just.
Maybe this seems like we're like like faculty. But I thought that would.
That's not actually that special.
Thanks, that's the end of it.
That just means I've never left school. I don't know, well. Let me know if you don't have this done.
I'm sorry.
Okay. This is how the sausage is made. Actually, it's probably not bad for you to be like. And it will happen more and more, me completely fail at stuff and like get out of it because. That's what it's gonna be like for you, so. Yeah, I did this on purpose to model proper troubleshooting behavior. Okay, so
Oh, also dumb question,
Yeah.
but like, because these are all the fast key files, like, is this something also we should have ever like pushed to GitHub or look at them, so look at their team?
these are pretty small,
Okay.
FASTQ files, they're real tiny on purpose, so. I wouldn't push them to GitHub just because best practice is to not
Yeah,
put data on there, and in fact, I'll remove them from my repository later today, but it won't hurt if you do.
so we should, like, if
Yeah.
this happens.
All right, so I'm gonna do the same thing. I'm gonna copy this. I'm gonna. Go into my biocomputing repository, go into lessons. Lesson 5. Seems we've already done all of lesson 5. All right, and I'll make my new script nano dl.show. Paste that in, save it, exit. Chmod plus x dl. And then There they are. Beautiful. Okay, everyone on the same page, we got the files now? Okay. Well, I'm gonna take a look at just the first two lines of one of these. Pick that top one. What?
Oh, no.
That one. The link to the GitHub page, not the actual file. All right. We're all gonna do this again, and I'll show you. Yeah. Okay, so if I click on this file, let me move this. I'm gonna click on this file and you'll see the top here kind of changes the path. Suddenly it goes into blob main resources. So there's the actual file. Okay. So we can download the raw file. But this right here, this URL, that's what I'm actually wanting. So let's see, it's data lesson 5. Let me just look at my download script. I've got tree main resources, data lesson 5. Here, it's blob main, not tree main. Okay. That should be pretty easy for me to fix. If I cat my download script, I see tree main. I'm gonna do a pipe. And then sed -i. Well, I'm gonna leave the -i off first, so just to show you. Single quote. S for search. Search for tree. Replace with blob. And sanity check for myself real quick. I should be able to go to that URL and see this little page. There it is. Okay, I'm happy. So with that said, bring it back up and do a little -i means edit in place.
I got an error saying like dash E expression 1 char 11.
So that works, but it didn't like save it as a file, you know?
Yeah.
So you could just highlight all those and paste them in, or to save it as a file. I'm saying sed in place. I'm going to edit this file in place. I'm going to search for tree, replace with blob, close it out there, like search replace, and then give it the file that download script.
So it should look like I ran that and then this is what it looks like.
Beautiful.
Is that?
Yeah.
Okay.
And you should just be able to run it and it'll overwrite.
I like when it's over.
Oh, perfect.
Great, sorry, I'm just.
Yeah.
What is it, the cat, and like the pipe that you just did, and then the sed down here?
I just wanted to see it before I like edited this file in place to make sure
So it
that it looks
edited
right.
it only to the print, not
To the
actually the
screen,
file, okay.
yeah.
Okay.
So the -i means it's going to edit that file without asking, are you sure? Without you knowing ahead of time. And so I was like, before I do this, let's
So the
type
reason
it to the
you
screen.
did that is because you had it, right?
Yeah,
You just
catted it
instead of.
and then piped it to sed and didn't say in place or anything. So to get it to edit in place, you give sed your command, search for tree, replace with blob.
Okay.
And then you give it the file to search and replace through.
Okay, next.
I just tried to do it like that. I go to said.
You didn't have a slash after glob?
Oh,
So I did. This and. It's like this. I don't know. I like to.
Let me see your download script.
Yep.
Glob name resources. And it's the same crap.
Yeah.
Did I screw this up again? And it, but what do the files look like?
So I did the head and then one of the file names.
So I may have screwed up again. This is cool. Today's going awesome. Okay. Yeah, they're all the same. Okay, so my download script, yet again. Oh, there it is. Fun. So the actual path is raw GitHub user content.com, gzone.com, refs, head, name, resources, data, let's find, oh dear. Okay, we can do this. So I'm gonna copy that and I'm gonna look at this and go, okay, resources, data, lesson 5. All right, what's different?
the
The
dot
Yeah, so from like here. Heads there, so from main on, it's the same, right?
Yeah.
Yeah.
All right, well, I'm gonna copy that business and. All right, how can I do this?
Did you do the same set of things?
Yeah.
But in the.
That's gonna be kind of tricky, but. Because it's gonna look real ugly and we've got slashes in there, but said like slashes, so we're gonna have to do this other trick. And so I'm thinking I might just do a little for loop here. Okay, so I've copied that. Great. So what I want to do is take the contents of this whole script and just pull off the last words. Right? And then paste all of them onto like this front part all the way to lesson 5. So I can cat, and I'll just make a new script for you and I'll stick it in the thing so you don't have to do this yourself, but watch me struggle. This is super embarrassing. I love it. All right, so I'm going to cat that and I'm going to pipe it to cut. That's one that we know. And my delimiter is going to be that slash. And I want field number what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There they are. Okay. So all of that, I'm going to pretend is a little file. And as a matter of fact, I want tail n plus, I want to start on line 1, 2, 3. There, so I'm getting rid of those first 3 blank lines. The first 2 blank lines. So that's a fake little file I've got. Okay. And I'm going to do a for loop for I in all of that stuff, each of these. do. Echo. All that stuff. Dollar. I.
Why do you do the brackets around the I again?
Safety.
Honestly.
It interprets I as the exact variable name. I. It's giving me the like, I'm still waiting cursor. So the brackets protect the I, it says this is a variable name, all the stuff before and after is not part of it. I see the problem, Control C, get me out of here, go back up. I forgot to close the quote. Okay. I need to change this a little bit.
What is the classifier?
That means give me all the final lines, but start on the third line. And if you go through the tail documentation, you'll see that in there. I want to add wget to that. There they are. So there's the actual stupid paths. I'm gonna go back into lesson 5 here. And edit that. Make it even tinier. So it makes it all on one line. All right, so that should be the contents of your download script. Yeah, let's go ahead and delete the old stuff because it's. And you can just like remove everything in that directory around star. If you're in that directory, don't do that. Don't do that in your like main biocomputing because you've removed everything.
Is there a way to like highlight multiple files? But
What do you mean?
like. We should be just highlighting the week, but obviously we can't actually highlight the week.
Control Shift K is delete a line
Okay.
on everything except Max. Command Shift K might work. No. There's going to be a Mac version of remove line.
Okay.
Okay.
Oh, different thing. Right. There's not just much to.
Okay. So I'm going to take that whole loop. It's spitting it to here. I'm going to just send it into download. So. Nano my download, paste it in. Okay. Got the files, they're 6.5K, that's what we want. It's actual data. Wow. Okay.
It's normal for the podcast.
It's totally karma.
I
I swear, like, yeah. I know how to do this stuff, I promise. Okay. Is it working for everybody? Got all the files? They look like this.
That's all we did.
I just did head, yeah. I didn't want to mark up the whole file, but just Just the first few lines,
What is the default? Kind of like the-
tens. In R, it's 6 for dramatic reasons.
Why?
Somebody wrote the head command in R and they had a fellow grad student in their lab who was like stealing all their work constantly. So they made the default 6 and hid that in the code. And so this person tried to steal it and say like, here's my stuff. It's like, why is the default 6? Got in trouble. Yeah.
Okay, so what happens so like.
Yeah, so in R it's 6, not for any real reason, but because it's petty, yeah, it's totally petty. Don't try to steal other people's work and you won't have petty stuff. Okay, we've got the files. Thankfully. This is a fast Q. You've seen a fast A file before, and what was the format for that? It's a defined file format. Header sequence, header sequence, header sequence. Usually. Sometimes fast A files is header, any number of lines, because they just wrap them, and then another header, but like, this is fast Q, the Q for quality, because it contains quality score information. So every sequence takes up 4 lines. Yeah, the plus is just like a little spacer. And
Okay.
I don't know, yeah. It's really not necessary, but it's there. Okay, so we've got a header again, like we've seen before, except this time it starts with at. And then the sequence itself. And then a spacer that starts with plus. It's not just a plus all the time, sometimes it has more characters, but it'll start with plus. And then this business here. You'll notice this 4th line is the same length as the 2nd line. There's a character associated with each character there, so they just like overlay each other. These characters are not DNA, they're quality scores, so each character represents some numeric probability of there being an error.
Like, what is like C and G then?
C and G are pretty good. If you know, I should probably put it in here, just the link. It's drive 5 quality bread scores. I'm gonna copy this. And paste it into our lesson. Just so you can see it.
It's like the same that universal sort
Of course not. It'd be great if there was one unified standard, but you can see we've got 2 different versions of these quality scores. For the most part, you will only see this top one. Okay. So this is just for old Illumina machines. Most of those are actually out of commission, but that data is still out there. And so, yeah, here's the ASCII character. Here's the probability of error at that given. Okay, so if you see, you know, an A, or what was one that we were seeing a lot of? C and G, great, okay. So if we see a C, boom, that's a quality score of 67. And the probability of error is 0.04%.
How is that determining the probability? Is this the like leakage from the photo?
Yeah.
Subplane,
Yeah, it's how tight the chromatogram is in that color, in that particular pixel. Okay. Yeah.
So the score is 67.
Sorry, the score there is 34.
Oh.
The quality score
Okay.
is 34. In base 33, 67 means C, capital C. So quality score associated with each base. These look pretty good. If you see letters, that usually means happy. That's kind of like how I think of it. But there's software that'll actually parse this out and tell us what the quality score looks like, so you don't have to memorize this by any stretch. Here at the end, I'm seeing like close parentheses. Right here, that's a quality score of 8, not great. Quality score of 20 and above is really good. That's usually kind of the cutoff that we use. Well, what's the point of having all this extra stuff here in the fast Q? And why wasn't it present in our fast A?
It's just like telling you like, we trust like whatever, like sequences for example.
Trustworthiness, for sure. If I have a sequence and it says, oh yeah, position 301 is a T, we got a thymine there. I'm like, oh, that's nice. And I look here and, oh, okay. We can back check that and say, that's got a 16% chance of being wrong. No, thank you. What do we do with that thymine at position 301?
You just like exclude it.
Goes away. You chop it off.
You leave a blank there, or
Mhm.
you leave a blank there, or you just like.
Depends on what you need to do. Yeah, you could leave it blank or you could just cut it. So blanks aren't super useful unless you're doing like the phylogeny and aligning sequences and looking for those gaps. But they can come in handy.
So if you're going to use a fast A, are you just not concerned with quality?
You found the question. Why do we have fast A at all?
Make it with fast be like actually usable, like it's assembly number.
This is still usable. It's not hard to write a bash script that takes just every first and second line from a group of 4. We can do that with sed. Why do we have fast A? Any of you ever worked with the older Sanger sequencing? Didn't have quality scores. Those data are still out there in a lot of GenBank. It's Sanger technology. So that's just a fast A, no quality scores associated with it. If you've got an alignment that you really trust, like the human reference genome, for example, that's been vetted really well. It works. We can design, CRISPR tags for that, and they work. That's a real sequence. Okay. Do we really need to double the size of the file? This file takes up twice as much space, and when we're talking about tera bases for big sequencing projects, that means a lot. So FASTA is smaller. Some older sequencing technologies didn't even give us quality scores. And then FASTA doesn't, it's just a file designation of every other line. Header, the sequence, header, the sequence. It also works for protein sequences. So you can translate DNA into amino acids, and every amino acid has a letter associated with it. You can have a FASTA file of proteins. That's very useful. Right? So that comes up all the time if you're doing metagenomics or metatranscriptomics or that kind of thing. You've got protein sequences, well, those don't have quality associated with them. That's just, here's the codon, it gives us this protein, this amino acid. So we still have FASTA floating around. It's there. Kind of like we use the quality scores until we don't want them anymore and we want to make our files small. Right now, I want them because I'm seeing bad bases in here. And so we can use quality scores to like chop the garbage off of our reads, especially at the ends. Illumina is famous for having really bad like, reads towards the end. So if I base 280 here, you're starting to kind of tank off. You can see it's kind of just ugly.
This, I don't know if this makes sense, but does having a reverse time help with that or not really?
Is that a reverse primary?
So
This is, yeah, this is the result of the more bases you sequence, the signal starts to get swamped out by other light sources. Yeah. It's that is a fundamental limitation of why Illumina reads are all short, like the longest one we get are 300 bases, because they just start to get really crappy. Now we've kind of solved this a little bit with newer sequencing technology, Oxford Nanopore, for these long read technologies. They don't get swamped out by light because they're not using light. They're actually physically pulling the DNA strand through a nanopore. And as it goes through, it is reading the electrical changes that its signature for each nucleotide. Very cool, but it's still pretty low throughput. And so you can get really nice long reads, which is awesome, but you don't get gigabases, right? So if you're sequencing a bunch of stuff at the same time, nanopore might not be the best. And so if you're trying to get a human reference genome, you want nanopore for long stretches, and then as we'll see, assembling. Long stretches are good to build a scaffold, but then you need depth of sequencing, and that's where Illumina stuff comes in handy. So if I'm getting a new genome of some fungus I found, I'm doing both. I'm sequencing long reads and with Illumina. But they don't come out with quality scores either. Not really the same way. So this is a FASTQ file. We've got, I don't know how many of them. Find out for me. That tells me there's 20. I said list everything one per line, but don't list everything, just the things that end in .fastq. Because I've also got my download script and interleave chop shut. And then give me the line count. Okay. So 20. How many samples? 10. 10 samples gives me 20 files. How come? R1 and R2, what's that? Why? Yeah, so we read it 5' to 3', and then we turn around and read it the other way. And so it does give us some quality assurance for sure. We're reading the same read twice. And that's an Illumina thing. It's real handy. So we read that same read twice, which means we got forward reads and reverse reads. So if I head, and I'm just gonna say SO90 star, we should get the first 10 lines of both of those sample 090. There they are. You see, it tells me like, oh, here's the ones for sample 1, here's the reverse. Now, if I look at the header, right there, and right there, no, I'm just gonna head. Here's the header. They're almost identical. That showed the 1, that showed the 2. So read one and read two.
You like, it's like, because when the ones at the end are the other one are probably better in the front of this one.
So we can merge them and get like a consensus. Well, let's see, for my read two, here's the quality scores. Oof. So we're reading it backwards, the crappy stuff up here at the end that I really didn't like. Right here will correspond with the beginning part of the same read. Reverse. And I'm seeing 8, 8, equals. Ooh. Let's see. We got an 8. Okay. Where's my comma? Right here. Ooh, quality score 11. So those are not great either. This is not uncommon that when you look at that, that's pretty trashy looking reads. Not seeing a bunch of letters. So the reverse reads for the sample are kind of crappier. Because honestly, it's getting like swamped out at that point. You read it one direction and you're already getting kind of crappy. They wash it off and go the other way, but it's still being swamped out. So reverse reads are always going to be lower quality on average than forward reads. Not to say they're not useful still, but they're not the best.
That's always R2 for the reverse.
Okay, so different sequencing companies will name them something different. Some just have an _1. This one returned it with a underscore read 1, read 2. I've tacked on the word sample here because this is just a tiny little piece of the original APSC file. We've got small stuff to work with. The point of reading it backwards is if we see the same letter in the same position both times, we can be even more sure that it's real. Yeah. So we've got some really common tools that we're going to start using that do things like merge all the reads. And essentially what they're looking for is match the header in both these files, take the sequence there with the quality scores and try to lay them on top of each other and find a consensus, and it will do a little sliding window until they match. So we could have this is another reason to read it both ways. It's like, what if we want to sequence something longer than 300 bases? We want 500 bases. We can set our primer to start here, end over there, and one sequences it up to here, and the other sequences down to there. When we merge them, we get a longer read. That's the principle behind genome assembly, is we have a bunch of short reads that we're going to try to find where they overlap and make longer. Okay. Well, got the files. Keep working on assignment 4 because it's due along with your quiz on Thursday. You finished with that, go ahead and see about playing with the next steps of lesson 5, but we will cover these in class because we're going through this idea of parameter expansion and how to build a bunch of variables from one part that have slight differences. And we're going to run stuff on all these files. First one is a script I wrote, which chops a certain number of bases off the end of these, right? Because like that's usually where the crappy stuff is. So you'd say, get rid of the last 20 or 30 or whatever. And then it interleaves them, meaning instead of 2 separate files, we're going to combine them into a single file where it's read forward, and then the corresponding read reverse, then the next forward, then the next reverse, and so. That's what that script will do, but we'll go through it in class next time after the quiz. The next quiz is what we covered in what, lesson 3? Yeah. Because we're on quiz 3, right? Yeah, streams and redirection line, yeah.